Welcome back, you guys. Wow, amazing. Good to have you all here. It's been a whirlwind of a month. Just, seeing all the things that have been happening. I'm so excited for Jason to be giving us another update. And then we're calling it an AMA, so an Ask Me Anything. Ruben, you can give them a little bit of an idea what we're going to be looking at today, and then Jason will dive into the presentation.
Absolutely. Incredible to be with all of you all over the world chat now. So for coming in for AMA, Ask Me Anything. So first of all, Jason is going to do his monthly update on the status of the build of our aircraft. We've all been dreaming about. It's coming very, very close. And then right after, we're going to have the normal Q&A session. So please put your questions on the chat, and they're going to be taking them one by one, Mischa and I at the end. And with no further delay, let's go for it, Jason. Please go ahead.
Thanks a lot, Mischa. Thanks a lot, Ruben, and welcome back, everybody, to the Hill Development Centre. So tonight's presentation is going to be covering five primary areas. I'll give you a quick update on the progress of the company. We'll talk a little bit about the drivetrain, so the engine and the transmission, and then we'll talk about the airframe, a little peach of information on the digital cockpit, and then we've got a little bit of an announcement for you on the upcoming second global meetup and discovery event for the HX50 customer base. So without further ado, let's talk a little bit about the company. For those of us that are joining this evening for the first time, Hill Helicopters is really all about the idea that the helicopter can be much more than it currently is today. More capable, more attainable, more desirable, more connected, and more owner-centric. And we're creating a whole community, a whole ecosystem for owners and users and operators to own and operate and share the joy of owning a helicopter better than ever before. To that end, it should be no surprise that what we're doing is connecting very well with the user base, and we're now up to 484 combined sales with 399 HX50s and 85 HC50s going out around the world. So we're absolutely delighted with the warm receipt that we've received from the market for both products. We're very, very grateful for that and the support that we're getting. To service this growing demand for aircraft and to really push the development forward and bring the aircraft to market on schedule. As you can imagine, we're having to grow the team and grow the facilities very quickly to keep up with all of this. So I announced, I think last month, that we'd been advertising for 8 posts. We've now essentially filled all of those. We've got 3 new engine specialists starting with us, a performance modelling specialist, a jet engines or a gas turbine engine stress specialist, and an aerothermal specialist, along with a new machining specialist that focuses on blade and bliss components. And we're also in the final stages of talks with some further combustion specialists and control specialists. So the team's growing, it's growing fast, it's keeping pace with everything that we need to do within the company. We've also started our routing systems specialist that's helping with all of the sort of cables, the electrical cables, hydraulic systems, flight controls, all of those things that most people don't really think about but are crucial to being able to close out the design of the aircraft. Rory's been with us since the early part of the year now, and is doing a great job getting all of the bits and pieces that need to go into the broader aircraft system, packaged and built into the airframe. So very pleased with the progress we're making on that front. In terms of the facilities, obviously we're having to continually develop the facilities here at the DC. Our in-house grinder that was installed just before Christmas is now fully commissioned and working, and our Mark, our lead production engineer, has just completed his training on the operating system for that machine. So that's now live, and we'll show you what we've been doing with that machine during the course of the presentation. As I sit here today, 2 of my engineers are on their way down to Heathrow to go and survey a very, very large gantry milling machine, which I'll talk about later in the presentation to support the pattern making for full-scale tooling development. We've purchased a tooling paste applicator machine, and our infusion pump for manufacturing in-house components is now expected towards the end of this month or early next month at the latest. So the facilities are growing. We're also making great progress on our factory as well. The first half of the acoustic trials have now been completed, and we're just waiting for the last of this crazy weather we've been having in the UK to clear, so we can do the flying part and do the source surveys for the helicopter noise. So we'll have an update on that very shortly for you, but very pleased with how the facilities are keeping pace with the needs of the program. So if we talk now briefly about the drivetrain, let's start with the engine this week. Essentially, we're now very, very close to a total design freeze on the engine. So what you will be aware of is we've, over the course of the last 3 to 4 months, switched to a much smaller, lighter, easier to build and easier to maintain version of the GT50 engine that features this compact compact diffuser and an annular combustor. The design of that is now nicely mature, and with the exception of the last couple of parts, we're essentially ready to launch a full-scale stress and lifing and optimization effort on that to allow those components to be released for formal prototype manufacture on the equipment that you can see right behind me. The performance, the weight, and the cost of the GT50 are absolutely bang on target. So we're absolutely delighted with how the team have progressed that for us. The compressor and the combustor manufacturing trials are already underway. So as we've showed you on a number of occasions, we've completed the first manufacturing trials on the centrifugal compressor. This is the 10-bladed version that we did. We're currently developing an updated version with its Curvix couplings and a reduced 9-blade, 9-splitter vane form factor. That's going to be cut in the next couple of weeks on the 5-axis right behind me. And we've also got the titanium on order to be able to produce the titanium version. I've got what's it in my ear? Sorry, just bear with me 1 second. I've got massive feedback in my ear. So we'll also be producing the titanium version of the compressor very shortly as well, and that will then release that part of the engine to testing. So very, very pleased with how that's all coming along. On yesterday, we actually managed to freeze the design of the starter generator. So the starter generator on the GT50 engine is a directly driven, fully integrated system. And the reason that we've done that is to get a far more compact and a far lighter, simpler and more reliable starter generator configuration. We've now frozen the design for that. We are well below our weight target, so the whole starter generator unit has been designed for just 2.7 kilos, which is about half of what a typical one of these units for an engine of this size would weigh. Again, the performance, the weight, the size, the cost targets have all been met, so we're right on target for being able to deliver that exactly where we expected it to be. The starter motor really consists of 2 parts. We've got the hardware, which is the electromechanical device that generates the power, but there's also then the control system, which for a small high-speed device like this is a bit more complicated. We're currently looking at 2 alternatives for the control systems for the starter generator. The first one is something that we're developing in-house using a derivative of some motor control technology, and the other one is some off-the-shelf components that we're working with a third-party organization to develop. So all of that's coming along very nicely. The performance looks great, the price looks great, so really happy with how the starter generator's coming together for us. So in terms of the overall engine program, what we've got to look at now is how we move from this nice mature design through to producing a prototype engine in the fastest time absolutely possible. And to do that, we've got essentially 3 major streams to the development program that are occurring all at the same time. In the first stream, all of the geometry that you can see in front of you on the slide, the compressor, the blisks, the nozzles, the casings, the secondary air systems, labyrinth seals, the combustor, all of that stuff is mature enough to the point where we can start developing all of the in-house processes that we need to be able to produce that. And that's exactly what we're doing. So while the aerothermal optimization and the detailed stress analysis that, to all intents and purposes, will only make very, very minor modifications to the geometry are taking place, we're busy producing all of the processes that we need to produce these parts on the machines behind me. So that includes the demonstration work that we've been doing on the compressor that I've already shown you. It shows the demonstration work on things like the speed reduction gearbox casing, the bearing work, the high-speed gears, and the nozzle guide vanes, and all of those things that we've introduced. All of that is going on in parallel with the final stages of the detailed design of the engine itself, and that's crucial to being able to get that thing on the bench by the summer as planned. We're also looking at some processes to expedite getting that first engine running. So whereas for the long-term endurance tests, it's vital that the engine is absolutely representative of the final manufacturing processes that we'll use for the aircraft, for the engine in production. For the initial prototype and the proving runs that we have to do, where we're just really checking core function, core performance, then we have the opportunity to tweak some of the manufacturing processes to make it quicker to iterate through those earlier tests. So we're looking at some material substitutions and some of the cast components we can actually machine from solid, which again brings all of those processes in-house. It allows us to make it on the equipment that we've got right behind us, and it really expedites that surge towards getting that first engine on test. So really pleased with how all of that is marching forwards. So if we look at some of the work that we're doing at the moment, this is essentially the rotating assembly from within the engine. The first three components are the gas generator rotor, so the impeller from the compressor, and then the two-stage gas generator turbine. All of these components, the work to develop these, to develop manufacturing processes for these, is going on right now on the machines behind me. So along that first shaft, you can see the ground assembly that we need for the motor generator unit. You can see the labyrinth seal blades. You can see the compressor's impeller. You can see all of the secondary air system passages and the through shaft lubrication holes. You can see the machined blisks that we'll be producing for the first version of the engine that runs on the test bench. And then you can see the power turbine assembly, which again will be predominantly machine parts for the first running engine. So all of that stuff is ongoing right now to get us to first run as fast as we can. Now, along with that, as we've talked about before, we've got all of the high-speed gear work going on, we've got the bearing work going on, the spring bar work going on, and all of the casings to support these components that's going on right now. So very pleased with how all of that's marching together. So again, just a summary of where we are with all of that. With the grinder now operational, Mark has this week been looking at the early stages of hitting those super tight tolerances that we need for aerospace grade bearings. So looking at holding single figure microns for all of the key dimensions to make sure the engine's smooth running, stable, and has the life that it requires. We've been turning blanks for a lot of these components on the lathe. So the lathe is now operational, ready to go. You've seen us produce the mast. The very next thing that will be doing is producing the titanium compressor blanks, and then onto the shaft blanks and the blisk blanks, ready to go on the 3 and 5 axis machines. All of the precision shaft stuff is now essentially ready to go in terms of manufacturing process development, as is the compressor production. Now, we talked previously about these nozzle guide vanes, which are amongst the most difficult components to make in the entire engine. Now, we've been working with a supplier to procure an EDM machine that is required to create the sealing slots and the cavities that are required to eject the cooling air out of the back of the blade. And I'm pleased to say that that's all going very well as well. So we've secured a short-term access to one of these machines to be able to make the prototype parts, and the procurement cycle for that is ongoing. Another area of interest that we've been pursuing very very actively over the course of the last month, is where we can make greater use of rapid prototyping. Now, with things like our castings, the bliss castings, the nozzle guide vane castings, and the engine outer castings, these are all investment cast components which require wax patterns to be produced, a ceramic slurry shell to be formed, and then that wax is burnt off and you pour the material into the shell mold. In terms of some of the components, in the kind of volumes that we produce, it might actually be more efficient to rapid prototype in a polymeric material the patterns for these moldings, and that's something that we're actively pursuing with a number of rapid prototype companies at the moment. So we're looking at rapid prototyping the patterns for some of the key castings to expedite the production of those parts, and we're even exploring rapid prototyping some of the bliss components as well to make this to expedite the surge towards production for all of this. The final area of development that we're looking at is the sheet metal forming. All of that work has now been ongoing for about 6 weeks, and we've got to the point where we've now commissioned an expansion machine which essentially allows us to hold the concentricity of the sheet metal rings that are required to form the annular combustor. We've also well along the way now with the press tools for the exhaust and also the end caps and the transition duct for the combustor itself. So pleased on all fronts with how that's going, and we're very much on schedule to get those components produced in time for the first engine run. If we now move on to the broader transmission for the aircraft, there's a similar effort going on for the whole transmission system for the aircraft. So we're very much moving the final stages of design in parallel with manufacturing processes. So the key area that we've reported to date on this is the parallel development of the gear cutting and the bearings, along with some nuanced optimization for stress, stiffness, lubrication and sealing that's going on within the gearboxes for all stages of the transmission system. And then, of course, one of the key areas that we're doing at the moment is one of the activities that's going on the 3-axis machine right now is we're producing the first articles for long-term fatigue testing of our gears. So this qualifies not only the gear cutting processes, but also the hardening processes and all of the NDT and everything else that goes into it. So those components are being cut right now, and that's what essentially gives us the confidence that we'll meet the lifetime requirements that we need for the gearbox overall. So if we have a look at the work that's been going on in detail to march us towards production for the manufacture of the transmission, then we've now essentially completed the manufacture of the first in-house gears. So we've carried out the tooth cutting. We've now manufactured 2 different sets of gears for the tail rotor gearbox, which I shall show you shortly. We've now got the measurement. The measurement of the hard machining for those 2 gears is going to be carried out in the next week or 2. And we've also now secured the full aerospace gear production process for every element of the process that we need to make these gears. Now, it's not just about CNC machining tooth profiles to the right tolerances. There's much more than that goes into producing aerospace grade gears. First of all, we have to be able to secure certified high integrity alloy steel to make the gears out of. We need to sort out the work holding and the tooling to be able to hold the super tight tolerances that are necessary for these components. We then need to be able to optimize our machining strategies so that we can productively generate these gears on the infrastructure that we've got here. There's then a whole process of plating to protect areas that we don't want to harden. And then there's the hardening process itself, the hard machining, shot peening to get the fatigue properties we need on the surface of the teeth, and then the NDT and inspection processes. That entire supply chain is now in place to support those gears, and we're ready to produce, well, we are in fact producing the test gears for the fatigue test articles, and then we will march through the rest of the gears for the entire platform. So very, very pleased with how all that's going, and we're again keeping very much to schedule with the delivery of that first gearbox. So if we just talk about the tail rotor gears for a second, I introduced in the Christmas update that we'd essentially almost completed the design for the gears in the tail rotor gearbox. I showed you last month that we completed the blank cutting, and over the course of the last month we've now completed all of the process development and the optimization for the tail rotor gears for both the driving gear and the receiving gear that picks up the drive shaft for the main rotor. So these gears are currently in the roughed state, which means that they carry about 1/4 millimeter of excess material on each tooth that's then ready to be plated and hardened and then hard machined to the finished geometry that will sit in the gearbox. So we're very pleased with how this has gone. The process is pretty much where we want it to be in terms of cycle times, and then these are off to be measured so we can actually optimize the cutting strategy and get the tolerances right on those over the course of the next week or so. And those are the actual gears that sit in the center of the tail rotor and drive the tail rotor. So very pleased with how all of that's going. In parallel with this, helicopters are obviously full not only of gears but also of bearings, and the fact that the grinder is now fully operational means that Mark is now busy developing all of the processes that we need to be able to produce a wide variety of bearings across the aircraft. So that includes the high speed stuff that's in the engine and the high load stuff that's in the top end of the main rotor gearbox. So the guys at the moment are looking at work holding strategies, refining machining ops to hold the tolerances, and then our first batch of in-house bearings will be produced shortly after that. So very pleased with how all of that's going as well. Okay, if we now flip over to the airframe for a second, there's a wide variety of activities going on with the airframe at the moment, following on from the successes of the third scale model. So as you're aware, we used a third scale demonstrator that you can see behind me to prove that we could produce this high integrity, high performance, stiff and strong and light and cost effective composite fuselage in a single piece. And just before Christmas, we successfully demonstrated that, and we're delighted to find that. What we've got to do now is march that to the point where that process is production capable. It's ready to go. And there's a couple of areas in the third scale fuselage where there are subtle areas that you would want to improve. Let me just show you a couple of those areas, for example. So if you just come over here, this was the very first third scale fuselage that we took out of the mold. And one of the things that's very important to HX50's aerodynamic performance is flush fitting windows, flush fitting doors, and to deliver that we need to create neat recesses with nice crisp edges so that we can close all the panels and have nice tight shut lines. Now what you can see here is that we've got quite blunt shut lines and we don't have a crisp finish line, and that's because essentially the fabric was we laid the fabric straight down into the mold without creating any real preparation to create this sharp edge. Now one of the techniques that you can use, if we just refer back to the slide, one of the techniques that you can use to create that is to use what we call a carbon fiber bootlace. And what you can see on the slide there is essentially we can use carbon fiber material and pack that into these tight corners to provide a non-structural carbon fiber filler that allows us to create a nice sharp edge to allow us to fit the doors and fit the windows and give you a kind of automotive quality finish to the exterior of the fuselage, while creating a nice smooth path to keep the fibers that are actually structural nice and straight. And we've been working very closely with CI to develop some of these things to make sure that they're ready as we're ready to go to full scale. In addition to that, we've also been recently informed that we've been nominated for an award by the JEC Composites Association for jointly again with composites integration for the work that we've done on developing an infused aerostructure as complex as the monolage. So that was some very welcome news a little while ago. The other big area that's a challenge for the aerostructure is the lightning strike mesh protection that we have to get into the fuselage. And again, working with CI, we've been finding some very intelligent ways to hold this mesh, because this mesh is like a copper net. and it really doesn't want to lay down. It doesn't want to stay where you put it. And so there's some challenges in terms of getting that to lay down in the areas where we need it. And the guys down at CI are busy developing those processes at the moment so that we can produce this really high quality fuselage when we get to full scale. So the guys are currently building a second third scale monolage, which includes not only the joggles and the carbon fiber bootlaces, but also the lightning strike protection mesh in a production ready example of the fuselage. So we're ready then to go to full scale tooling. So if we talk about now the very next step for the production of the fuselage, which is again a two-phase program where we march the final structural optimization, the development of the plybook forwards as we release the A-surface tooling to again minimize the lead time to be able to produce this thing. Now, when we produced the third scale model, this was essentially relatively crude tooling that was produced straight out of model board. Now, if you remember the tooling strategy that we've got for how you produce this thing at full scale, we've got a very large rollover rig that's about 6 meters long, and then this 5 or 6 piece tool that allows you to address all of the areas and lay all of the fabric down and get those bagged up. Now, the problem is if you try and do that at full scale, then the direct model board approach for making the pattern simply becomes too heavy, too expensive, and too slow. I think we worked out when you start looking at either these epoxy tooling boards or the polyurethane tooling boards, I think we end up with about 17 tons of this stuff to be able to just make the patterns, and a very large bill for materials. So one of the things that we've been looking at is how we can bring knowledge from across industries to be able to do this in a more practical and a more cost-effective way. So other industries make composite components that are much, much bigger than aircraft. And so what we're doing is we're pulling some of the technologies from boat building and wind turbine blades into how we make the patterns that we then take the tools off for our larger composite parts. For small things like doors and cowls, then model board patterns are fine. For things like rotor blades, then you'd obviously go to metal patterns, metal tools and carbon tooling. But what we've got here is a way to make very large scale tools very cost effectively. And essentially what we do in this case is build a support frame, use a much lower cost foam base that machines very, very quickly. We apply a fiberglass sealing layer to the top of that, and then apply this same material, this tooling board material, but in a paste format. So the paste application machine that I told you about essentially can deliver this like a toothpaste, as you can see in the slide on the screen there. And once the stuff's delivered, nice thin layer, so you only use the minimum amount of it that you need, that goes off, and then that can be CNC machined to the same finish and the same tolerances that we can achieve with direct model board tooling. So that allows us to make these big tools much faster and much more cost effectively than would have been traditionally possible. So then the question becomes, well, how on earth are you going to practically machine something that big? So the guys have been very much involved in looking at different machining strategies, different ways to get this stuff done. And two of the areas that we've been focusing on particularly are robot milling, which is an area that's used for boat building and other large scale pattern making and model making, and also gantry milling. Now, the robot milling is great. You end up with a robot that's not just a milling machine. It can also trim the final patterns, and it can also do all sorts of other things, but the tolerances are nowhere near as good. That thing can typically only work to about 0.1 millimeter. Whereas what we've fallen in favor of is a conventional gantry milling machine. Now, these machines for this particular application are faster. They're about 4 times more accurate. There is equipment available right now, which is where my guys are off at the moment, just doing a survey on the kit to assess whether or not it's acceptable. If that's the case, we can have the equipment here within a couple of weeks. And this is a much more typical approach for these kinds of tools. So essentially, over the course of the last month, we've taken all the findings of the third scale model. The FEA has been marching on in the background, and the guys have put a concerted effort now into working out the strategy as to how we tool this accurately, cost effectively and practically in the shortest time possible, so that we can get this first fuselage built and on a test rig. And we've made huge leaps forward with that over the course of the month. So in order to be in a position to do that, in order to be in a position to freeze the fuselage design, commit to A-surface tooling, there's a whole manner of other elements of the design that need to be frozen to allow us to commit that level of expenditure to the tooling. Now, one of the obvious areas is all of the duct work and all of the location points for the climate control system. And Rory, our systems engineer, has been busy looking at all sorts of ways of delivering a compact, lightweight and simple climate control system. We've got your conventional air conditioning system, most of which is buried in the nose beak on the top of the fuselage of the aircraft. But rather than ducting, rather than having to provide ducts all around the aircraft, one of the things that we're evaluating at the moment is the use of modular electric heaters. Because we've got essentially a somewhat generous electrical provision on the aircraft, we've been investigating the defogging capability and the heating capability of small modular heaters for the aircraft. So Rory's been doing some tests on that, and that all looks very positive at the moment. So over the course of the next month or so, we should be in a position to finalize that and get that baked into the fuselage. There's also a lot of other very non-glamorous but extremely important work that needs to be done, to do with the door hinges, to do with the access control, to do with the central locking systems, and all of these sorts of things, the way we make the glazing, and all of that work has been going on in the background. We are in fact in the next couple of weeks going to make the first tool to do a windshield, an in-house windshield for the aircraft, so that we can look at the processing parameters that are necessary to maintain the optical performance we need, along with all of the adhesives and coatings we need to apply to provide a really high performance windshield. On top of that, Martin's been busy looking at all of the necessary detail to fit the seals, to provide weather seals, wind seals, and everything else we need to fit those doors securely, so that the people that live in colder parts of the world are kept nice and warm, and here in the UK we're kept nice and dry. And then finally, all of the things to package the trim and package the avionics and electronics have been ongoing as well, to allow us to finalize those aspects of the design. So we're all very familiar now with our rather Gucci automotive-esque interior for the aircraft. And I've reported in previous months how we've spent a significant amount of time optimizing the ergonomics, making sure the 5th and the 95th percentile are properly accommodated, making sure the view angles work properly, optimizing the user experience, and detailing all of the functional requirements of the seats and all of that stuff to make that work. But of course, there's much more to an aircraft interior than just that. One of the primary areas that we have to be very careful about is the crashworthiness. And so there's a lot of work being done on the carbon fiber seats. And in particular, recently, we've been looking at the energy absorption mechanisms that are required to maintain the loads in your spine below a certain level, to make sure that in the event of a vertical impact, you're able to get up and walk away. And that's something that's been going on over the course of the last week or so. So Tim has been down at the Cranfield Crash Centre, carrying out a detailed series of trials on the first of the crush tubes that we've manufactured for our crashworthy seats. So we showed you last month the quasi-static tests that we were doing to look at the force displacement history. We've now done the dynamic testing on the crash tubes to demonstrate that we can maintain the levels of energy absorption and the force displacement characteristic that we need during a rapid impact. Now, these tests have been conducted to the EASA CS27 impact criteria. It's the same for the FAR Part 27 criteria, and we've essentially successfully now validated the crush tube. So we have a carbon fiber crush tube that meets the crashworthiness requirements that we need, that now gives us the confidence to move forwards and put that into a full-scale crashworthy seat. We've tested both a single tube and a dual tube design. I'm only showing you the single tube design here. And the single tube design looks to be a more practical option for us. There's all sorts of intricate modes that you've got to manage with the two tube design. And just for interest, what you can see there, when the impact occurs and the carbon tube is pulverized, it's that pulverization that absorbs all the energy. So it's all that surface area that you create that absorbs the energy that protects your spine in the event of that crash. So the very next step is to employ the services of this brave chap, strap him into a seat and a portion of a fuselage, and then to repeat that test and prove that these crash-worthy tests not only meet the energy absorption criteria on a part-by-part basis, but can also make sure that the forces related up to the vertebrae in the crash dummy's back are where they need to be for the certification requirements. So very pleased now to be in that position, to be able to move the seats forward to a point where we can drive those to completion as well. So let's talk now about the HeliMove system. So the whole point of HX50 is we're trying to make the experience of going flying as simple and as straightforward and enjoyable as possible. And that's not just about our user interface, that's not just about the airframe, it's about everything. So it's about from the moment you try and pull your aircraft out of the hangar to the moment you put it away. And to that end, we've been developing our HeliMove system, which is essentially a series of small motor drives in the wheel hubs that allow you to pull the aircraft in and out by a smartphone app. And essentially, to develop that system, what we need to do is work out what the smallest, lightest and simplest mechanical arrangement we can have is to deliver those outcomes. And to do that, what we needed to do is physically run some tests on the actual wheels and wheel hubs. And so to do that, we've built what we call the HeliMove rig. And over the course of the last couple of weeks, we've been able to get that out into the field and test the HeliMove rig and measure, using strain gauges and torque transducers, the amount of torque that's required to do all of the sorts of things that the HeliMove system will be required to do. So moving over smooth tarmac, spot turns, climbing over broken concrete, transitioning over soft ground, and dealing with all of those sorts of things. We've done that, we've carried out those trials, we've gathered the data, and we're now very pleased to report that the data is very much where we expected it to be, and both the harmonic drives and the size of motors that we were aiming to package within the hub are exactly where we need them to be. So we're now in a position to go ahead and finalize the sort of design and packaging of the HeliMove system and get that thing ready for HX50. So really pleased with how that's all moved on. As somewhat of a surprise, we had a request from a gentleman called Rowan Wilson, who's the founder of Oz Runways. Now, Rowan's a very experienced and successful app developer and also a HX50 customer. And in order to escape some of the COVID restrictions in Australia, he decided to bring his family for a holiday here in the UK. And while he was here on holiday, he decided to come and do a few days' work for us. And Rowan's been busy developing the HeliMove app part of the Hill app, which now allows us to essentially control the HeliMove system that we've just demonstrated on the rig via a smartphone app. And so the app provides a very simple user interface where you can command the movement with a single finger or by directly controlling both of the wheels. It gives you haptic feedback so that you can tell when you're in positive control of the aircraft. And Rowan went and built a little simulator so that we could test the usability of this. And the thing's basically now sat there ready to be hooked up to the rig for full-scale testing. In addition to this, Rowan's also been helping us with the app management of the flight data recorder stuff as well. So really delighted with how that's come along as well. And then finally, in terms of the digital cockpit, you'll be aware that we've been wrestling with the idea of a 2-screen and 3-screen solution for the digital cockpit. That was very much about, can we physically host all of the apps that people want to use for navigation on the third screen in the center of in the center of the cockpit. We've now managed to start exploring this with ForeFlight, which was one of the areas that was the biggest concern for us. So I'm pleased with how that's moving, and we should be able to report back to you very shortly as to whether or not we're going to be able to support not only the Android apps but also the Apple apps as well. So more news to come on that, but I'm pleased with how that's going at this point. And then the final point is we've now set a date for the next HX50 Global Meetup and Discover event. So this is a live update that's going to come from the Hill Development Centre. You get to meet the team as you did last time, see all of the major developments firsthand, network with the community, and we'll be providing some lovely refreshments as well. And I'm not going to say exactly what's going to be there, but we're planning something very big for you for this one. So we look forward very much to seeing as many of you as possible on Thursday, the 11th of August this year. And so at that point, I'm going to call it a day and look forward to answering any of your questions. So thank you very much for your attention.
Okay, wonderful, you guys. We've had lots of questions coming in here. We're going to go through all of them here in the next little while, but Jason's just getting his audio set back up again. And Jason, can you hear us again?
Okay.
Are you there, Jason? You can hear us now?
Yeah, I'm back.
Okay. Perfect. Excellent. So first question that came in, it says, with superior unmatched aerodynamics of the HX50 and the great engine design, might fuel efficiency be better than projected, as we're going to be pleasantly surprised? Will flying at a speed slower than 140 knots increase the range?
So fundamentally, I expect that you will be pleasantly surprised with the performance. We do have some reserve in terms of the aerodynamic performance of the aircraft, so I think speed will be a little bit better than what we've declared openly. In terms of the fuel consumption, it's likely to require less than 400 horsepower to deliver the 140 knot cruise, in which case then yes, you can expect to have higher range than we're talking about at the moment. In terms of the out and out fuel consumption of the engine, when that engine is delivering 400 horsepower, I wouldn't expect the fuel consumption to be any better than what we've declared. We haven't left a great deal of margin because it is actually very difficult to make small uncooled gas turbines fuel efficient. So we've pushed everything as far as we can while still having the confidence that the machine's going to deliver the life and the reliability that we need. So yes, I think you'll get a little bit more speed. Yes, I think you'll get a little bit more range. But when you're asking for when you're pulling max continuous power, then it will burn 35 gallons per hour. I wouldn't expect an improvement there.
All right, and also please bear in mind, everyone, that some of these questions might be already answered in previous sessions, but we want to make sure that all the questions from the current audience are answered. Okay, so some of you question, Jason, is in remote missions with jet fuel unavailable or in an emergency, can other fuels be alternative? Like you have talked about the biofuel in early update. Can you elaborate on some types that might be available, like kerosene or any other diesel?
Yeah, sure. So fundamentally, gas turbines are fuel flexible engines. The challenge is that we have to qualify the engine for use of each of these fuels. So at the moment, there are only plans to qualify the engine for the standard grades of jet fuel, so Jet A1. And then in addition to that, we'll be qualifying it next for some of the sustainable aviation fuels and biofuels. So I can't elaborate yet on exactly what grades we're going to use because it's very much a developing area. So expect it to be fully qualified to run on the conventional aero jet fuels. But in terms of other fuels, while technically it would be possible to run it on those fuels, it's the sheer cost of the endurance testing that we would have to do to make sure that the engine maintained its life and reliability with all of those different fuels that make it more difficult for us to prove that.
Perfect.
Sorry about that, guys.
Okay, so we're going to go to the next question. So next question is, will the HDC, the Hill Digital Cockpit, show all of the aircrafts flying in the area on the screen within 10 or 20 miles? Is there a cockpit technology developed that shows large birds within a few miles as well?
So there's no plans for the Digi Cockpit to show other HD50. So you've got your basic traffic systems. If you have the traffic option that will report any aircraft, as all traffic systems do, it doesn't selectively filter out HX or HC50s. It's a conventional traffic awareness system. In terms of big birds, I'm not personally aware of anything that would identify that as a threat at the moment. There are some vision systems being developed, but they are in very early stages. They're not in a position where we could apply them to the aircraft just yet.
All right, the next question is still about the HDC. We'll have a global wire map and wire warning. It will be great to have every wire displayed.
Yeah, it would be great to have every wire displayed. You have to understand that those wire databases are based on databases that are pulled together from all sorts of natural infrastructure providers. And so we're reliant on the databases that we get from people like Jeppesen and what have you to provide that data. So you can't rely on the wire database as an absolute carte blanche protection. It's not a wire detection system. It's just a wire awareness tool for wires that we physically know are there. So as the pilot, you still have to be responsible for seeing and avoiding those sorts of hazards, I'm afraid. Again, there's lots of vision system technology that people are trying to develop for these sorts of things, but it's not there yet. It doesn't work terribly well, it doesn't work to a level where it's ready for application in manned aircraft.
Okay. The next one is, you talked about the GT50 having 20,000 cycles, but we haven't heard anything about that lately. Are you still aiming for the 20,000 cycles?
Yes, we are. There's no change to that. We're still targeting 20,000 cycles. When we come to do the engine development, there'll be a series of different tests. One of the tests is the engine cycling to build these cycles up as quickly as possible, while the other one is dealing with the 5,000 hour on a more representative duty cycle over the course of a flight hour. So yes, that's still very much the target for the engine. That's what the engine's been designed to do.
On the heli move, we saw the demo test of the trolley bogging in the grass. This might be a good reason to use kids, Jace.
Oh no! So I think we showed that in the interest of total transparency, and there is obviously a limit to how boggy the ground can get before it does make more sense to go to either bare paws or skids. But you have to understand that the guys did that test after some of the worst weather that we've had in the UK for at least this year, maybe a little bit longer. So we'd had a couple of weeks of almost constant rain. 2 days after that, the test site flooded completely. So that ground was so soft you would have struggled to walk on it. So it's not really representative of the kind of ground that you typically land on. So I wouldn't make too many judgments about the capabilities of wheels based on that. The under more realistic ground conditions, you'd be fine on wheels. So don't throw the baby out with the bathwater.
Okay, sounds good. Is it possible to get external power to accept 220 volt for preheating and charging? Reason is operating in Norway on emissions.
Got nothing on the platform. Sorry, I didn't get.
Did you get that,
the
Jason?
platform dropped out.
That again? Okay. Is it possible to get external power to accept 220 volts for preheating and charging? Reason is in Norway, remote places and often cold weather operations.
Yes, So the system is designed for remote power. You can power it with 220 volts. There are some limits to what electrical systems you can power while that's going on, because there's a limit to how much juice you can physically get out of a conventional domestic socket. So we're looking at what it's practical to deliver, but I think basic cabin heating would be fine. Air conditioning is more of a challenge to have that on long term. But yes, you'll be able to trickle charge, and you'll be also able to do things like battery heating and some heating of the cabin as well.
Okay. Which blade rotation will we use? Single pilot operation, is it right seat? And these are one of those have been already answered many times, but you can go over that. But also another addition to that, any movable weights to adjust CG?
So the pilot will fly from the right seat ordinarily. And there are no removable weights. HX50 has a active fuel system, so a trimmer tank in the nose that provides for exceptional CG range. So you can load this aircraft up with anything from a 70 kilo solo pilot with a lot of bags in the back through to 5 95 kilo passengers in each of the seats, and still be within normal operating range for CG. So we've worked very hard not to fall foul of the obvious CG problem that you would get if you make an aircraft with a high useful mass fraction and then make the fuselage bigger as well. So we've used the trimmer tank to solve that problem. So no movable weights.
Okay. So the question is about the situation that's happening between Russia and the Ukraine right now, and do you see the HX program possible issues of getting
Sorry, Mischa, I got as far as Russia and Ukraine.
Okay, so talking about with the situation over in Russia and the Ukraine, do we see any issues with getting supplies or time increases or prices increasing, anything like that?
So we don't have any visibility of that at the moment. So it's not affecting us right now, but it is obviously a concern. So a very substantial amount of titanium comes from Russia and Ukraine. I think Russia and Ukraine are responsible for almost the entire global supply of Xeon, which is required for silicon chip manufacture. And there's an awful lot of other very valuable things that come out of Russia and Ukraine. So it will have an impact on the global supply chain. It's not affecting us yet. We haven't been informed of any delays to the titanium we have on order or the nickel alloys that we have on order. So it's having no impact at the moment. I think we have been seeing upwards trends in some of the materials, but that's been an ongoing thing since the COVID pandemic, and we think that should wash itself out over the next year or two. But obviously the tragic situation in Russia and Ukraine is a fast developing situation. I don't think anybody can fully answer that question just yet. We don't have any reason to suspect we'll have to increase prices. But there's a lot going on out there at the moment. So no, I don't expect to increase prices.
Right. What is the material you're planning to choose for the leading edge? We fly often in heavy rain, and erosion is an issue on the leading edge. Did you get that, Jason? Hello?
Hiya.
Yeah, okay. What material, you hear me now?
Yeah, I can hear you.
Yep. What materials are you planning to use on the leading edge? We fly often in heavy rain, and erosion is an issue on the leading edge.
We're looking at two solutions at the moment, a stainless steel erosion shield and a nickel erosion shield. So ideally we'd stick to stainless steel, but we might, for forming reasons, end up having to use nickel around the tips of the main rotor blades just because of forming constraints. So that's the plan at the moment, and that is a very robust solution.
Okay. The next question, I think, is a repeat, but we can just do a quick rehash on it. Will there be a traffic avoidance system built into the avionics? If not, will there be a 12-volt socket that you can link your own system like Flarm?
The simple answer to that is yes.
Okay.
All right. Interested to XFN fabrication. Seems like it will be greatly reduced parts count and allow lower rate production without massive tooling investment. Seems like you're trying to have very broad vertical integration. For example, designing your own bearing versus buying with schematics or other established aerospace vendors. So probably the question is more, elaborate a little bit more on the vertical integration strategy.
Okay, the vertical integration strategy is absolutely vital to what we're doing here. What we've found is that the aerospace supply chain is very much geared towards servicing the needs of the major commercial air transport manufacturers and military contractors, and those platforms that have very high ticket prices can afford to support higher part costs from their subcontractors and their suppliers. When you scale it back down to general aviation and you're trying to pitch an aircraft at broadly the same price as a very high-end supercar, then those kinds of margins just can't be supported. And ordinarily, you wouldn't expect to be able to buy the kind of equipment and the kind of tooling that we're buying. And within a few tens of units produced have made back what it would have cost you to buy those parts from third-party suppliers. So the usual economics of outsourcing as applicable to normal high-volume industry really doesn't apply to aerospace, because the prices that we're expected to pay really don't bear that much resemblance to what it costs to make stuff. And so it shouldn't be this way, but it is. And it means that although we have more work to do now in terms of process development and manufacturing development and upfront tooling costs, it means we have complete control of our unit prices, and it means that we get to add the most value that we possibly can to the aircraft. So we only bring raw material in the front door, we add the most value, and then we send a premium product out the front door. And that's what gives us some isolation against external price increases. It gives us the most isolation about other costs that aerospace manufacturers have to carry, and it gives us the ability to really drive this product out there at a price point that will reinvigorate the market. So I don't see vertical integration as a choice. I think it's a necessity to deliver what we've set out to deliver.
Okay, and the next question dovetails sort of right into that. It says, there are so many bearings in the HX50, but there are so many bearing manufacturers in the world. Is there nobody that can make and sell a standard size bearing at a reasonable cost with traceability certs?
Not that we found the moment they realize what it's going into. The prices of these things are absolutely intolerable. So no, we haven't found anybody, and we've talked to all of the players that you would trust to make these things. So unfortunately, we have no choice.
Right. Apart from surrounding cameras, any idea on incorporating proximity sensors like in cars?
Yes, we'd love to do it, but not now. I think it would be a real value add to the HeliMove application. I think it would be potentially a value add if the user interface could be done properly for landing in confined areas. But that's a whole development project in its own right. So it's something that we'll look at later.
Okay. So Richard's question for the AMA, Ask Me Anything. Can you please give us the expected times for the full-size fuselage, frozen engine design, running engine, flying prototype, and also with the growing number of orders, is the original delivery estimated for serial number 350 still going to be around the beginning of 2025?
Okay. I'll try and remember. I'll try and remember all of that.
A lot of stuff there, Dave.
So in terms of key dates. Summer is the key date.
Frozen engine.
Well, let's go back to the big ones, which is engine running on a bench and fuselage. We're aiming for the summer for that. Now that's no margin, no wriggle room for Jace. That's what we're aiming for, and that's what we're working towards at the moment. And so obviously the frozen engine design and all of those things come substantially before that. In terms of the delivery times, it's a curious byproduct of all of these orders that we're at some point soon we have to choose how big this factory's got to be, and we penciled in a sort of 250 unit starting production rate for the first year of production based on where we thought the sales would be at the point that we had to commit. I think there's growing pressure on us to revise that upwards, in which case if everything else stays the same, then it might be possible for the delivery for serial number 300 to come forwards a little bit. But there's an awful lot of stuff got to happen between now and then before I can commit to that formally. So as it stands at the moment, we're under real pressure to increase the production volume, because again, as we deliver a running engine, as we deliver an airframe, as we do the first flight, the sales are just going to get faster and faster. So we have to keep up with that because we can't keep people waiting too long.
Yeah. All right. So what percentage of components are expected to be manufactured in-house, and how many outsource it?
In-house, in terms of the mechanical components, pretty much anything. We're outsourcing some control cables, we're outsourcing the sprag clutch, and that's about it. Outsourcing the tires, all of the structure, all of the mechanicals, all of the rotor system, all of the windows, all of that's manufactured in-house. So it's a very, very high percentage of the essence of the aircraft is manufactured in-house. We obviously don't make LCD screens, we don't make microchips and things like that. But if it's mechanical or aeronautical, it's probably us that makes it.
Okay. So we've got somebody saying they're a little bit confused. This is their first time here. I'm just trying to understand the question here. Is there a product to buy today, or is it in development? If the latter, is it possible to refresh the target dates for launch and delivery?
So HX50 and HC50 are currently in development. Our timeline that we're working to is that we will have an engine first run and a fuselage by the summer this year, and then we're aspiring to first flight around the end of this year. And then in terms of production, we're in production in the summer of 2023, but we're already sold out until roughly middle to late 24 now. Ruben, I don't have that off the top of my head.
Beginning of 25.
Beginning of 25. Mm-hmm.
Beginning of 25.
Beginning of 25. Okay.
Mm-hmm. All right. Are there any renders of the co-pilot's side collective? I'm just curious to learn about how it works or will fit. So can you elaborate on the left side collective?
Yes. So I don't have renders to hand, but we do have images of it. Now, essentially, you've got the same collective grip, but it is arranged more like a conventional collective. The reason for that is if you had the fore and aft action that we've used in the pilot's side, then when the collective is fully down, it completely blocks the pilot's door. So we've essentially just taken the same stick, moved the pivot point further back, so it just becomes an up and down action like you're used to. So entirely conventional, but still consistent with what we have the other side. So the range of motion is the same in terms of the travel of the head. So the sensitivity of it will be the same, and the grip is identical on the end.
Okay, wonderful. And Richard's asking, is there anything that he can do to help with the registration or the acceptance of the HX50 in Slovakia? So I guess talking about the permit to fly in Slovakia.
Sorry, Mischa, I missed that one. Can you say that again?
Yeah, no problem. Richard's asking, is there anything that he can do with the to assist with the registration or acceptance of the HX50 in Slovakia? So the permit to fly with the authorizations there.
Not really at the moment. All of the subsequent national approvals will piggyback off the UK approval, and the most expedient way to do that is get a watertight UK approval in the first place. Make sure everything's in order, everybody's happy, all the compliance showing is done and is accepted, and then we can go with a nice homogeneous set of compliance showing information and certification information and take that round all of the other authorities at that point. I think if you try and do it before you get it to a mature state, all that will happen is we'll have the same questions, the same queries from 42 different national authorities, and we'll just drown in work processing that. So let us get the core materials right first, and then we'll push that around all the authorities as fast as we can.
Are the crash tests you're doing now sufficient for eventual certification, or do you need to redo them later? I imagine this is about HX50, HC50 crash tests. Can they be used for certification later?
The objective of all of the testing that we do on HX50 is that it will carry over directly. So there's nothing nothing lower grade about HX50 to HC50. There are some approvals that need to be in place before this work can be registered, which we're actively working with the Civil Aviation Authority on at the moment. But fundamentally, all of the compliance showing testing that we do for HX50 is intended to be carried over.
Okay, this is a great question. It says, will the crush tubes that are being used for the seats, will they be contained so that in the event of a crush in an accident, that you won't have carbon fiber bits flying around the cockpit?
They'll be contained to some extent, but you need the carbon fiber bits to fly around. Otherwise, you run the risk of packing the enclosure that you're trying to contain them in and preventing that tube, the anvil that drives down and crushes the tube, from moving in a predictable fashion. So we do need to eject that stuff out of the way, but it should be caught by some of the seat upholstery and all of those sorts of things. So it's more important that we allow those to get away from the crush front so that the tube can do its job properly.
Any further thoughts about insurance? Specifically, do you expect to have an insurer that would be able to insure Hill helicopters around the world, or at least in Europe, for a reasonable amount? Jason? Jason, can you hear us?
So yeah, I think I got the question. Okay. Then it broke. So yeah. So insurance around the
You want me to repeat it
insurance now? Around the world. Was that the question?
Yes. So what are the thoughts about what can we expect of an insurer that will be available to insure Hill helicopters around the world, at least in Europe?
So our primary focus at the moment has been on the hull insurance, and that will definitely be available everywhere around the world because that's going to be partially underwritten by us. In terms of liability insurance around the world, so your third-party stuff, we haven't done anything on that yet, but we will also be trying to tie that in with the insurance that we provide. So we expect to be in a position where we can provide a single source for coverage around the world.
Okay. Will the FADEC have an auto relight function?
Yes.
Are you going to be in Heli Expo 2022? Well, I can answer that one because it's happening in about a week or so. No, we're not. Yeah, so that's an easy one. Yeah. But you can give your thoughts there if you want, Jason. But our strategy is to be present once we have the aircraft to showcase. Yes.
Yeah. There's not really a great deal of value in us being there at the moment. The most important thing for us to do right now is to be here, getting this aircraft and engine working, and we're fundamentally focused on delivering that. There's lots to do. There's lots that needs my input and the input of my key people, and so we're really focused on that. We're a small team, so if you start pulling key people out, then the wheels move much slower. So we need to be here engineering this aircraft at the moment. As soon as we've got all of those things in place, as soon as we've got an aircraft, then we'll reevaluate it. And I know Ruben and Mischa are keen to attend those things at some point in the future, but we'll evaluate that on a year by year basis. At the moment, we won't be there this year. We may be there next year.
Okay. And of the work that you've completed so far, have you met your estimated times?
Yes, I would say so. Yes, we have. I think what happens is when you get into stuff, it's a bit like peeling an onion. There's more and more detail the more you get into it, so you end up doing extra things that you weren't necessarily intending to, or opportunities arrive, like the extent of the vertical integration that's been required. But yes, I would say we're pretty much where I expected to be by this point in the program. I think we're entering a phase of the program now where there are more external factors. Availability of materials. We're starting to ramp up the workforce, and so the availability of people to actually do the shop floor work and things like that, where those sorts of things can have an impact. But fundamentally, in terms of the core engineering, yeah, I'm pretty much exactly where I expected to be by this point.
And somehow related, I think you answered that, but just adding, is there anything you're not pleased with on the expected budget or timeline, or something they're behind?
I think the thing about being an engineer is you'd always do it differently the second time. So if I knew what I knew now, I wouldn't have entertained the 3-can combustors. We spent a lot of time and money developing an engine that was fundamentally too big and too heavy, because we were trying to avoid the technical risk that arose by squeezing that diffuser down, because we were worried about the amount of time that it was going to consume going out and using third-party test centers. In the end, we couldn't use the third-party test centers anyway, so it made absolutely no difference because we've had to do the test rig in-house. So there's things like that where if you could go back and do it again with what you know now, you'd change. I think we've probably spent too much time, or I've allowed some of the guys in the team to spend too much time pursuing suppliers and trying to drive down prices with suppliers, when it's been my view for a long time that they were never going to get close to the price point that we needed, because they have no, it's not in their best interest to do that. So I'd have probably cut that a bit tighter if I could do it all again. But other than that, no, I'm pretty happy with how most of it's gone. We haven't had anything that I'd call a big problem crop up yet. It's marching on pretty smoothly at the moment.
Mm-hmm.
I like the way you put that, Jason. You're constantly putting up fires, but I like the way you put that. This is a repeat question. We've had it many times in the past, but for those that haven't heard it before, will the aircraft be IFR capable?
Did you hear it?
Sorry, it dropped out. Next question.
Okay. So this is a repeat question. We've had it many times, but for those of the people that haven't heard it, will the aircraft be IFR capable?
No, at least not initially. Making a helicopter IFR is a very big deal. You have to deal with de-icing, you have to deal with stability. It needs a much more complicated hydraulic system, much more in the way of avionics, dual electrical system, and all sorts of other stuff. So it's a very, very big deal to make a helicopter IFR capable. And then, of course, if you make it IFR capable, you essentially turn a helicopter into an aeroplane, because you've still got to let down at an airport. So it's something that we may do in the future, but it requires such a large amount of technology development that it's not one for now. It's a VFR day and night helicopter.
Update on that.
Did you get that?
Yeah, we got that. But now the next one is any news on the factory, status of the factory?
Yeah, we've completed the first part of the acoustic trials at the factory. So all of the background measurement trials have now been completed. We've been held up due to the weather. The wind has to be below about 10 knots to be able to actually do the flight trials there. But it looks like we should have a window in the next couple of weeks to be able to go and do that. And that's really the thing that's holding up the planning permission at the moment. So as soon as we've got that, we're able to march forward with the final part of the development of that and get going with it.
Okay, sounds good. Again, this is a question that's been asked many times, but what kind of a bird strike will the windshield be able to support?
So we essentially comply with the Part 29 transport category regulations for bird strike. So it meets the same requirements as all the big aircraft. Now you'll have to forgive me, I'm saying this off the top of my head. I think it's a 2-kilo bird just above the VNE of the aircraft. But I'd have to go and check that off the top of my head. I haven't looked at that for ages.
I believe I heard you say it was 2-kilo bird at 200 knots.
Yeah,
that's the last time that you said it.
Yeah, yeah.
How involved can we get on the build of aircraft of our HX50? Will it be limited to the first 2 weeks? So 2 weeks, or will it be more? Did you hear that one? No? How involved can we get on the build of our HX50? Will it be limited to just 2 weeks, or there'll be an opportunity to be more hands-on?
I think you should probably work on.
Time.
No, I've got it. I think you should work on the assumption that it will be the 2 weeks. There might be an opportunity to do more, but obviously we've got an awful lot of people to get through the build school now. I think the basic build school goes far above and beyond what's required by the 51% regulations, because it's part build school, but it's also part education to make sure that everybody that owns and operates a HX50 is fully aware of how the whole system works. So the build wouldn't require you to know anything about gearboxes or the inner workings of how an engine goes together, but part of the build school course does cover those things so that you understand how these things work and how the broader aircraft systems work together. So you'll get to see all of the key manufacturing processes that go into making the parts, not just the bits that you're required to do by the sort of 51% requirement. So it's a very, very involved course anyway, from an educational point of view, even though it's delivered in a streamlined and efficient manner.
Okay. Any thoughts on the landing gear design being a trailing link landing gear?
Oh, this is a thing that hasn't gone well. So we started with a trailing link design because I'm a big fan of trailing link designs. But unfortunately, because helicopters have a very significant sideways landing load case, the fact that trailing link sticks out the back puts a huge torque up into the airframe. And then to make the undercarriage legs and to make the airframe strong enough to carry those extra loads, you end up with an undercarriage system that's about twice the weight of a straight vertical leg. So purely from the point of view of minimizing the weight and maximizing the strength of the aircraft, we've been forced into using a straight undercarriage leg just by letting the science and the physics lead.
Can you talk about fuel tanks? Are you using bladders, and are the seats and trim parts made in-house?
So in terms of the fuel tank, they do include bladders. So you've got a carbon fiber shell that's an integral part of the airframe, which then contains a bladder, and then within the bladder we put a foam product that helps avoid sloshing, and that applies to both the main tank, which is behind the aft cabin bulkhead, and also the trimmer tank in the nose of the aircraft. So that's how the fuel tanks work. And then in terms of the trim, that's open at the moment. We've got a supplier that we'll be talking with over the course of the first half of this year to look at potentially outsourcing kits to actually produce the seat covers and the trim panel covers and all of those things, and that will be traded off against doing that in-house. If the price point is right, then I'd be more than happy for that to go out. So yeah, that's the status with that.
Okay. When do you expect to have compliance acceptance done in the UK CAA? I'm asking just because our CAA is, let's say, conservative, says the question.
So inevitably, the compliance is the very last thing that you do. So we'll be developing compliance showing material and all of the certification materials and type approval materials all the way through the program. The first of those reports are being prepared at the moment, but it will take the CAA a reasonable amount of time to be able to audit those and to approve those, to be able to release the approval. And of course, they can't do any of the flight testing until the aircraft's there. So I would expect that to be literally just before we start production. It'll be the part of the program that essentially defines the start date of production.
Could you provide us with some ideal helipad measurements? This is probably more for Mischa, right? But for the HX50, what is the ideal helipad measurement?
I think there are various piloting bodies around the world that are best placed to provide that information for individual territories around the world. We've had a few customers send in pad geometries for us to run our eye over, and they always seem to be a bit on the small side. I think you have to consult your local regulator, and you have to consider the location for the pad as much as the performance of the aircraft. I don't know if you want to add anything to that, Mischa.
Yeah, I think depending on where you are in the world, also depending on the class of the aircraft, that affects the size of the helipad. So that's not a specific one that I think can be answered, but yeah, it'll be different in different parts of the world. But I think if you had a 12 by 12 helipad for landing on, for the most part, you'd be pretty good. So 12 by 12 feet. Next question is, what is the max height of the HX50 on the wheels, and what weight will HeliMove option add to the aircraft? So as far as height goes, I'm not sure if you have that off the top of your head, but on our website in the exterior concept, if you scroll down, there's full dimensions of the whole aircraft, but you can go ahead there, Jason.
Yeah, that's right. So the full dimensions of the aircraft are on the website. And I can't actually remember off the top of my head what HeliMove adds. I think it's about 15 kilos. I don't know what we've currently got on the website. It's about 15 kilos in total.
All right. Regarding warranty, can you confirm the standard warranty for the HX50, and if there's going to be additional extensions on it?
Yeah, so the standard warranty is 5,000 hours or 5 years, whichever occurs sooner for a machine in private use. And then, yes, we will be offering warranty extensions. So as you're aware, we've been talking about subscription-based maintenance and extended warranties and things right from the beginning of the program. And that's very much a an avenue that we're pursuing. So it's very important to us that as these aircraft get older, then people that are in the market for second-hand or older aircraft can still be assured of a predictable operating cost as the aircraft age. So the sort of power by the hour systems or the annual cap cost maintenance is something that we will be offering.
Okay. Next question is, are the windows dimmable to keep the heat out?
Not electrochromatically, no. So the roof lights and the rear windows are all tinted. There's less of a tint on the pilot's windows and the windshield, but then they're not adjustable. All of the windows have sort of UV, IR coatings on there to reduce the amount of heat and UV radiation that gets through. But again, those are also passive coatings, so they're set at a specific level.
What is the capacity of the building school? How many people can be building at the building school at the same time?
So it's sized for 250 aircraft per year at the moment, and that'll be groups of 5 per week, but that's likely to go up.
Okay. I think the question was more around how many people could be building one aircraft at the same time, I believe, but I might have misunderstood.
Okay, yeah, well, I can.
But the next question is,
yeah, I can talk to that. So it depends very much on the ownership status of the aircraft. So if it's an individually owned aircraft, then the owner would have to build 51%. If so they'd have to come and essentially do the build tasks themselves. That doesn't stop them bringing somebody to shadow them or to enjoy the educational parts of the course with them, but they will be responsible for delivering that 51%. When the aircraft is owned by multiple people or is syndicated to a group, then the group ownership applies. So more people would have to be involved in the build as well.
Okay. The most aviation authorities don't allow night operations in a non-certified aircraft. How is this going to be solved?
Because the limitations that apply to these aircraft are based on the initial airworthiness, the basis for initial airworthiness. Now, in our case, the basis for initial airworthiness is EASA CS Part 27 or FAR Part 27. So if you deliver an aircraft with the same certification basis as a fully certified aircraft and you produce it develop it by a design approved organization, produce it in a production approved organization, then you can quite easily justify it should have the operating privileges of an aircraft that's come out of that environment. That's how we do it.
Have you managed to ensure that the door closes flush to the body without having to compromise the smooth exterior shape? This is a question actually that comes up several times. And people want to make sure that door closes well, Jace. So, and also does not affect that smooth exterior shape. What can you add there?
Yes, we are. So that very much comes down to a trade-off between the stiffness of the seals and the amount of material that you want to put into the door to make sure that the door is physically stiff enough to compress the seals without deforming too much. And there's all sorts of juggling that we have to do to balance all of those parameters, but fundamentally, yes, the doors will close flush, and then we're using some of the automotive tips of the tricks of the trade, creating underflush edges and things like that to make sure that the small misalignment that's inevitable in any built artifact isn't perceivable. So yes, you'll have that smooth exterior body.
Okay, next question is related to your sleeping habits, Jason. How do you sleep at night with things like the incredible cost of the aircraft, including the high cost of CNC machines and so forth? Did you catch that, Jason? No.
Yeah, you're back.
Can you
Sorry,
hear us, Jason?
I'm not
Can you hear us?
avoiding the. I'm not avoiding the question. It dropped out at that point. Can you give me the question again?
Yeah, just wondering, how do you sleep at night with the incredible high cost of building an aircraft and the cost of expensive CNC machines and so forth?
Okay. Well, I think the first thing to understand is that I'm doing what I've always wanted to do. I'm having the time of my life developing this aircraft. And it's just a thoroughly fulfilling, enjoying and exhausting experience doing it. So sleeping's really not a problem. And I think one of the most empowering parts of the whole process is the fact that I'm very aware that all of the customers want exactly the same thing that I do. So me and my team want to develop and deliver this aircraft. All of the customers want to buy the aircraft, and we're in this together. So it's not a difficult thing to cope with when it's all you've ever wanted to do. And of course, the other thing that's gone a lot better than I expected, quite honestly, is the huge support that we've had from the market. You know, we've got far more cash and sales, and we're in a much better financial position than I ever expected to be at this point. So I don't worry about things like that. We're in a position, we're in a very nice position, we're in a position to deliver, and we want to do what our customers want from us. It's a perfectly symbiotic relationship.
Yeah, you have the dream job, Jace, right? You've been dreaming for.
Yeah.
You're delivering the dream helicopter, but having the dream job.
Yeah, I've got no idea what's going to happen to me afterwards.
All right. Will there be a factory-approved ferry tank, or do we need to get local approval for a ferry tank from our local regulator?
I have been asked this by one of our very early customers. So yes, we will do a ferry tank. It'll be something we do towards the end of the options list. So there's some other options that are much higher priority than that at the moment, but we will do a factory approved one. But of course, you have already got a 5-hour fuel tank that, if you fly at best range, will do much better than the figures that we're talking, that we're openly declaring at the moment. So it depends just how far you want to go. It can already do sort of 700 miles.
Good. Can the HX50 be owned by an LLC, even if for personal use, or do you have to get the commercial certified HC50 for that?
No, it's quite common for aircraft to be owned by all sorts of corporate entities. People do that to protect personal liability, and amongst other reasons. Most syndicated aircraft are owned by a company structure of some form. So no, that's fine to my knowledge. It's certainly fine in the UK.
If the heli move is not chosen by the buyer, will there be an area in the nose wheel for a tug bar?
Yes.
Easy one.
Okay. For instrument added on the HX50, is all antenna will all the antennas be hidden, like the horizontal and the other antennas?
Yeah, all of the standard and
Or
the standard.
Sorry, and the other.
Yeah. All of the standard and the standard equipment on the options list will involve antennas that are embedded within the airframe.
Okay, and the last question we have here is not really a question. What a way to almost end. Let's see if we have more questions. It's not a question, is you're doing an awesome job. So that was a good one. It was not planned. But
thank you very much.
And let's see if we have any other questions. Anybody else? It was great. We had 51 questions up to now. And let's see if we have anybody else. Any other questions? If you don't have, we'll be closing very soon. Anybody else wants to ask a question? There you go. You can go ahead. One more.
Perfect. How much sound and heat insulation do you have in your design?
Not a lot. So in terms of the fuselage, there's some sound insulation being developed into the interior trim materials. There's obviously a firewall around the engine bay to protect as per the requirements. There will be a form of acoustic silencer on the compressor. and we're toying with the idea of trying to build something into the exhaust for the engine, but I think that's quite unlikely at this stage. So at the end of the day, it's a helicopter, and we have to manage weight very carefully, otherwise we just eat into that useful payload. So the cabin will be on a par with what you're used to in terms of light helicopters with a reasonable interior.
This is a question that comes up several times, and I think there's a misunderstanding, Jason, which is, so the 51% build takes 10 or 14 days?
It's 10 days, 10 working days.
Yes, correct. So 10 working days, but since you're going to be working 5 days a week,
Yeah,
that means you need to be there for 2 weeks.
yeah.
So
Bank on being here for two calendar weeks, 2 full weeks, but the actual working hours are 5 calendar days.
Mm-hmm.
Yeah. Okay. 10 calendar days. Yeah. 2
10
weeks.
calendar days. Yes. 5 days a week.
Can you elaborate on your? Yes. Can you elaborate on your plans to support iOS apps? Example, ForeFlight modulo mounting an iPad.
I can't on this forum, unfortunately, because it's early days with them. All I can say is that ForeFlight thus far are very keen to work with us, and we're very grateful for them to do that. But it's early days. They're exploring what's possible, and as soon as we have that in place, we'll report back more openly. At the moment, it'd be inappropriate for me to comment any further on that.
Can you explain how the blade fold system works?
So this is something that's in a state of flux at the moment. Originally, we had planned just to be able to pop out the pin in the lag damper and allow the blades to swing around their other mounting point. We're now developing a sort of quick release mechanism that will be in the root of the blade, outboard of the Speriflex bearing, so it's away from the hub cowling, and that's something that's under review at the moment. So there'll be more information on that coming over the coming months. And at the moment, it's an entirely manual system.
The question is, what is? Yes. Okay. What is the order count at this point? So I think you went over that at the beginning. 399 on the HX50s and 85. I believe it is, so on
it's
the HC50s.
484. I think we're at in total.
Okay. And next one is, when will you have the next cost adjustment? I imagine it is price adjustment. We're right now at the 399, as we mentioned. So we have one slot left under the current terms. And after these are sold out, it's in one aircraft, there's going to be a new price adjustment again. We'll let you know once it's launched.
And how are you? Yes. How are you dealing with galvanic corrosion?
A variety of ways depending on the location in the aircraft. So in terms of the metallics that are built into the composite components to connect the transmission and what have you, then all of those metallic components are actually embedded in glass fiber before they get infused into the cockpit. So there's a protective layer of glass fibers that are non-conductive to act as an insulating barrier around those parts. And then obviously there's more conventional methods for dealing with dissimilar metals throughout the engine and the airframe.
Okay. Any chance for fly-by-wire?
No. Yeah, it's something that we may look at in the future, but that's a step way too far for us at the moment. It has lots of interesting opportunities in terms of the control layout, in terms of dramatically simplifying flying a helicopter, but it's a whole new area of technology that's not core to what we're about at the moment.
And Jason, why did not? Oops, there is a change here on the question. Let's go for the next one. It just disappeared. No, here you go. No, there is a new one. Okay, for scheduling, what do you expect for the normal time for the build? flight checkout and mechanic training to be? And can there be a schedule or in a consecutive block? So, and can it be they be scheduled as a consecutive block?
To be quite honest,
Mechanic and flight. Yeah.
The logistics of that hasn't been thought about in any great detail yet. So in terms of scheduling courses and things like that for the mechanics, we really haven't given that a great deal of thought. We'll obviously take feedback from the customer base and take into consideration how people want to do that. But yeah, it's not something that I've directed too much attention to yet at the moment. I'm focused on delivering the aircraft.
Okay. How can, sorry, is the HX50, sorry, if the HX50 is purchased with a limited company, are you able to claim back the VAT?
That's a question for your accountant, I'm afraid. I think you'd have to show that your business has a legitimate need for you to move around by helicopter. But I can't offer you any advice on that. I'd probably get away with it.
How can an owner get an HX50 desk model? Well, we have great news. This is already available, Mischa, right? We just made it available very recently.
Yes.
And anybody can order.
Gary, you can email us if you want to, and we can get you a link for that. Yeah.
Yeah, it's not us that we do it. It's a partner that does all the big, all the main desk models of aviation, and they were very keen to do ours. And after a long process, they have it available, so ready to order desk models.
Yes. Okay. And this last question we can answer, I think, ourselves. It says, I did download your app, but do you have to order a helicopter to get a login? Yes, it's a very expensive app. It's the price of an HX50, and then you get a free helicopter. Yes, it's a community owners app. So once you become an owner, then you get access to the app. Yeah.
And it's full of great stuff.
It is.
It's full of great
stuff.
A lot
of friendships.
And Jason does weekly updates on it. So it's wonderful.
A lot of friendships have been made worldwide. Yes. It's a great community and very active. That's why we're going to be also doing the second event with the same as this. The owners meet the Munster and announced in the beginning it's going to be on the 11th of August. So very soon we're going to be getting together again. My Arius 2F diffuser cracked around the brazing and sent metal into the turbine, resulting in a forced landing. Any brazing in the GT50?
Nope.
All right, answered.
Okay. How much of a difference do you think there will be in the design over the first few hundred units?
Very little. There shouldn't be any. There shouldn't be any differences. There'll be differences between the very early prototypes, so PP1, PP2, and PP3, as we iron out the problems during the development. But when we get to PP4 and 5, those should be production representative, and thereafter the aircraft should be mature.
Actually, that's a fair, common question that people ask. They say, "Oh, wait a little bit because the aircraft's going to be developed further as you're going to be manufacturing more units." And that was a clear answer from Jason. So it's going to be a frozen design, and those are going to be manufactured for some time, long time. Correct, Jason?
Yeah, absolutely. You see, there's a big difference with what we're doing and what some people have done in the past, in that this aircraft is going out the door with a very, very generous warranty. So what I can't have is machines being unreliable and breaking and creating warranty claims in 42 countries around the world, because that would be disastrous for us. So the level of time and effort that we're putting into shaking out those problems on test benches and with extended flight test programs is vital to making sure that we deliver that. And for that reason, and for the reason that you're supported with such a generous warranty, you can have confidence that when both ourselves and the aviation authorities decide it's good to go, it's good to go.
Okay, clear answer.
Wonderful.
Well, we don't have any more questions. Let's see if we have
Yes.
anything else, but we're getting very close to 2 hours. It was a great session again. And let's see if we have anything else. That's the right moment. Otherwise, we're going to be wrapping up here. And again, we are reaching the serial number 400. We have one aircraft still available under the current conditions. And here we have one more. How much automation are used to building and manufacturing? It's probably going to be the last one. Then we're going to close after this one. Go ahead, Jason.
The last one, yeah.
Lots. So we use a lot of state-of-the-art CNC machinery, a lot of the composite, although the prototype composite stuff is quite manual, but the productionized version of the composites in terms of fabric cutting, fabric kitting, fabric handling, mold manipulation, all of those sorts of things will be highly optimized and automated. So we absolutely use the latest automation to make sure that the process is as streamlined, as organized, and as repeatable as is humanly possible. So this is a very, very modern way to build a helicopter.
We have just one last one, and I just want to go over this one. This is really important. I tried to contact Dr. Hill by email, but he has not replied to my emails. Well, so first of all, Jason Hill needs to build a helicopter. Okay, so Mischa and I, we're available for most of the questions. And obviously, there has been an incredible development of the team and Jason's availability for anything that we can answer. We're here to answer that. The question is there anybody interested on selling the earlier serial number with the huge discount that they had? But I imagine that those that actually ordered at that time, they ordered because they were early adopters and they were very compensated for that. And that's their decision if they want to sell that position later or sooner or whenever they want. The contract allows that. So that's something of the owner's decision solely. And Mischa, we have a couple more. We're going to handle these and then we wrap up.
Yeah. Sure, sounds good. I think actually, Ruben, just reading the question again, I think it's actually the opposite of that. He says, my question is, would someone in this chat be interested in buying my helicopter since it's a low serial number and a huge discount in price from what a buyer would pay today? So I think it's a question of, is there somebody interested in buying an earlier serial number? Okay.
There you go.
Yes, we can go over that. Yeah, if you want to get in touch with us, Troy, we can put that out there for the owners group as well. Absolutely. Which certified helicopter would you compare the HX50 to in handling characteristics? So just a couple more questions that came in.
The closest one is probably the Gazelle and the EC120, but with a slightly easier tail rotor handling characteristics. So in terms of power, perhaps the Gazelle. In terms of the hub design and the flight dynamics, perhaps more akin to the 120, with the exception of we've got a slightly easier to handle tail rotor.
All right, so we are reaching the end here, and go ahead, Mischa.
Yes. No, I was just going to say that I think that's the last question, but giving the date for the next monthly update, so that we've decided that one's going to be on April 7th, I believe it was.
April 5th.
So April 7th. You guys are all going to be getting
5th, Mischa. April 5th.
The 5th.
Tuesday, April 5th. Exactly.
Okay.
That'll be anybody that's already enrolled. They'll be receiving automatically the reminder, and anybody new joining, you're going to be also receiving the link. If you join our list, you're going to be on the website. You'll be receiving the link for the next update, which is going to be on the 5th of April, Tuesday. So thank you very much, each one of you, for taking the time to be with us today with this one more Q&A session. Ask Me Anything. We had a lot of questions. We had about 70 questions. It was great to have you all. And Jason, thank you again for your time. And again, all the owners make plans to be together again on the 11th of August. That's a great opportunity for any owner to see a live demonstration of the build of the aircraft. At that time, as Jason said, we're going to be very, very close to many things that are going to be very exciting. And it's going to be a great moment to see each other again. So thank you again, and see you on the 5th of April.
Thank you.